Welcome family. In this video we are going to look at mathematics paper 1 and we are going to just look at question 23 from this paper of 2023. Now the question reads, the following diagram is a speed time graph of a car. The car starts from rest and accelerates uniformly at 3 meters per second for 4 seconds until it reaches a speed of v meters per second. It then travels at this constant speed for 8 seconds. It finally comes to rest after t seconds. Now if we look at our given diagram here, let's put a 0 here. So from the first part, we are told the car starts from rest. So this is the rest position. So the rest position, it is the position where the car is not moving. And at that position, the initial velocity, which is u, must be equal to 0. So this is our initial point. It's very important to identify the initial point. Then it accelerates. So the acceleration for this line, we are told it's 3 meters per second squared. Now, if you remember, or if you have just understood this fully, whenever there is acceleration, the velocity must be changing. So the velocity changed from 0 up to a v meters per second. So at this point, v represents the final velocity, the velocity that we don't have, that we are going to find. So at this point is the final velocity. Now from 0 meters per second to v meters per second, the time taken was 4 seconds. So now how can we use this data? How can we take advantage and find the value of v? So the value of v is the final velocity. The formula is final velocity v is equal to u initial plus acceleration times time. Final velocity is equal to, since the initial is 0, we put 0 plus the acceleration is 3, the time is 4. If we do the math, we have 0 plus 3 times 4, 12. 0 plus 12 is 12 meters per second squared as our final answer. So here is 12. We move on to question B. For question B, average speed for the first 12 seconds. So the formula for average speed, we need the distance for that particular time. So we are going to find the distance, then we divide by time. Now time is given is 12 seconds. So from 0 seconds up to 12 seconds here, what distance was covered at this shaded part here? So this is where we need to find the distance. So let's find the distance at this point. Now if you look at the shape here, this is a trapezium. So distance is equal to half a plus b times the height. Distance is equal to half. A is this distance, this line here. So we don't have the number on top here, so we need to move in the x-axis. So if we move down here, it is giving us 4. Then also here we are getting a 12. So we need to find a difference between 4 and 12, which is 8. So 12 minus 4 will give us 8 plus. Then the base, which is b, is gotten from 0 up to the t, which is 12. Then the height is this one here. So the height, if we go in the y-axis, is the number that we calculated, which is 12 here. So let's do mathematics. We have half. 8 plus 12 will give us 20 times 12. Now we can say 2 into 2 is 1. 2 into this one is 6. 6 times 2 is 12 times 0, which is, times the whole thing, which is 120 meters. So the distance from 0 up to 12 seconds is 120. So we can now find the average speed. So the total distance is 120 over 12 seconds. So 12 into 12 is 1. So the final answer is 10 meters per second as our average. Now we are done with this one. Let's go now to the last part. So to the last part, we need to think very carefully. Okay, so now let's look at this question. How can we handle a question like this one? Now, question C, value of t. If the speed at t is equal to 14 is 4 meters per second. Okay, so what is this means? Now, remember here is 12. And for this point, for this deceleration, this is our new initial point. Now, whenever the car is decelerating, the initial is always greater than the final. So the final is at this point. Now, don't confuse t to be the final. No, t represents time, but the final velocity at this point is 0 because it came to rest. From this point, we are told it finally comes to rest after t seconds. Okay, so that's what we are. So at this point, the final, whenever the line touches the x-axis, then the final velocity is 0. So the initial is at this point, which is 12. So 12 meters per second for the last part becomes the initial point. So we have the initial and the final. Now what we don't have is time. Now, as this line is coming down, if we are moving down, there was at a point where the velocity was 4 meters per second. Because of this, look at this, 4 meters per second. So when the velocity was 4 meters per second, the time at that particular point was 14 seconds. So at this time was 14, this given value here. So if we have this, we can find the deceleration. So now for us to find the deceleration, we are going to consider 2 points. First 2 points. Let's consider this point as point A, then point B. I'm going to use point A and point B. So this is my final, my new final here. So let's find the acceleration. So acceleration is equal to final minus u over t. Acceleration is equal to my final at this point, final velocity is, if we go in the y-axis, is 4 minus u. The u is 12 over the time from initial to final, from 12 to 14 is 2. 4 minus 12 is negative 8 over 2. Here must be 2. So acceleration is equal to negative 4 meters per second. It's negative because it is coming to rest. So if we are able to find the acceleration, and if you look at this line here, it is a straight line. So this means that the acceleration is constant. So now, since we have the acceleration, we are going to use the acceleration to find the final, the t here. So remember, the acceleration for this line is negative 4 meters per second squared. Now, since this is constant and it's uniform, let's ignore this. We have used this point to find that. Now, we are going to consider this point and this point. So we can say, say if acceleration is equal to v minus u over t. So over 1, we cross multiply a times t, at v minus u over a over a. So for us to find the t, we are going to divide final minus initial over acceleration. Final at this point is 0. initial is 12 over the acceleration. The acceleration was calculated as -4. So t is equal to 0 minus -12 is -12 over -4. So the negatives will cancel. 4 into 12 is 3 seconds. Now this 3 seconds is not a final answer. This means that from 12 up to t, or it took 3 seconds to move from the initial, which is at this point A, up to the t. So for us to find the t, we are just going to add 12 plus 3, which is 15 seconds. So t, this value t here, is equal to 15 seconds. So that's how you can find. Or if we want, we can do the same. We can use that part here. We say this is our 4. So if we want to use this part, let's do some changes so that you see the point here. So let's consider this is our new initial point. If this is our new initial point, then let's consider this one as our final. So to find t, we know that t is equal to final minus initial over acceleration. Final is 0. Initial for this point, if we start from here, the initial is 4. Over the acceleration is -4. 0 minus -4 is -4 over -4. -4 into -4. -4 into -4 will just give us 1. So if we start from 14 is 1. So 14 plus 1, we are still getting t is equal to 15. So those are the two ways in which we can find this answer. So if you find this video interesting, give it a like, and thanks for watching.